So today is November 25, 2025. Okay. So, dear members of the Dissertation Council, dear colleagues, let me begin. According to the order number 1.1-02/75 NK of SD University dated July 4th, 2025, the permanent composition of the Dissertation Council for the defense of the dissertations for the degree of Doctor of Philosophy PhD in the field of 8D06102 Computer Science and the specialty 6D070400 Computer Engineering and Software at SD University has been approved in the number of 4 members. Bogdanchik Andrei Vladimirovich, I'm a chairman. Then we have Professor Vitaly Rivashenko from the Jelina, Slovakia, Al-Haditi Mohamed Ala Fathil from our staff, faculty members, professor, and Dana Utibayeva is scientific secretary of the Dissertation Council. Also for this meeting, at the meeting of the Discussion Council for the Defense of Dissertations for the degree of Doctor of Philosophy, PhD in the field of 8D06102 Computer Science regarding the review and acceptance of Bauyrzhan Berlikozha's PhD defense, the permanent members of the Council, in accordance with the requirement of the regulations on the Dissertation Council of SD University, appoint 3 temporary members of the Dissertation Council. They are Aygiri Mirimbetova, PhD Associate Professor, Research Professor, School of Engineering and Information Technology, Eurasian Technology University, Almaty. Also, Bauyrzhan Umarov, PhD Associate Professor, Mathematics Computer Modeling, Department, International IT University, and leading researcher of the IM Rodosbekov Institute of Mechanics and Engineering of the CEO of the Ministry of Science and Higher Education of the RK. And also Tolegin Akhmetov, PhD, Visiting Scholar, Design and Augmented Intelligence Lab, Daily Human Ecology College, Cornell University, USA. So currently we have, except 6 members of the Dissertation Council. Okay, present 6. 1 professor unfortunately couldn't attend, Professor Levashenko. Also, okay, the quorum of the holding of the council meeting is met, so 6 is enough. Out of the 7 members of this Dissertation, 6 participate in the meeting, which is more than 2/3 of the total composition. Among them, considering the nature of the dissertation under review, are 3 members, yeah, or 4 members. Okay. The meeting is deemed legitimate. 2 official reviewers also present online. Okay. It is proposed to begin the work of the Dissertation Council meeting. Are there any objections? No objections. Okay, we continue. We begin the work of the Dissertation Council meeting. The agenda includes the defense of the dissertation of Bauyrzhan Berlikozha on the topic of AI-powered approach to career path prediction for IT students using academic and behavioral data in the educational program 8D06102 Computer Science. The dissertation was prepared at the SD University. The defense will be held in English. The defense is being conducted for the first time. The dissertation is presented in the form of dissertation work. Official reviewers for his work are Madina Mansurova, candidate of physical and mathematical science professor, head of the Artificial Intelligence and Big Data Department, name it after Farabi, Almaty, and also Rustam Abdurrahmanov, candidate of technical science, executive associate professor, International University of Tourism and Hospitality, Turkestan. Are they present? Yes, they were. Okay. And also the scientific consultants for our current student, PhD student, are Azamat Jamanov, PhD in Specialty Engineering Informatics, Associate Professor Information Systems Department at the University, and also the external consultant, scientific consultant, Oliver Diaz, PhD Associate Professor, Faculty of Mathematics and Computer Science, University of Barcelona, Spain. Okay, they're present. Are there any questions regarding the agenda? No questions. Wonderful. Let's continue. Then I request approval of the agenda. Who is in favor of this agenda? We're in favor? Yeah, we should start. Okay, we can begin. And no abstentions. Then agenda is approved by open vote. Now I give this floor to Academic Secretary of the Council meeting, Dana Utibayeva, to review the personal documents of the candidate Bauyrzhan Berlikozha and their compliance with the established requirements. please.
Thank you. Good afternoon, dear colleagues. So for the defense of the dissertation of Bauyrzhan Berlikozha, who is PhD candidate from SDU University, on the topic AI-powered approach to career path prediction for IT students using academic and behavioral data in the educational program 8D06102 computer science, the following documents have been submitted. If we mention application from the candidate, reviews from domestic and scientific supervisors, positive conclusion from the department, and also ethical conclusion, all other higher education diplomas and other documents. So all documents submitted by the candidate are complete, and we can process the defense further. So thank you.
Thanks. Are there any questions for the secretary of the PhD candidate regarding the personal file materials? Are there any questions regarding the materials? No? Okay. Thank you. The floor is given to the candidate for the presentation of the main points of the dissertations. Please proceed. 20 minutes are given for the presentation. Please share the screen.
Okay, thank you. Let me start. My name is Bauyrzhan Berlikozha. Today I'm going to speak about my dissertation topic, AI-powered approach to career path prediction for IT students using academic and behavioral data. My internal supervisor is Professor Azamat Jamanov, and the external supervisor is Professor Oliver Diaz from Barcelona University, Spain. So, the relevance of the work was divided into two parts. Relevance to our country and global relevance. Kazakhstan is rapidly increasing their digital economy by making well-prepared IT essential professionals, and this work is taking into account real data from the SDU University by Better Career Program, suggesting the recommendation system for predicting the career position in a field. And globally, this work is very important. In the world, the higher education system is improving their systems by artificial intelligence. And the findings of this work can be benefit for Kazakhstan and for other countries to develop their higher education. And here are some related works which are directly connected to the relevance, and these articles are published at Scopes-based, and these works are highlighting the long-term benefits of digital transformation on employability. Problem statement of the work. The problem statement is that in the market there is a lot of many job suggesting systems which are taking into account on the academic aspect of the students by ignoring the behavioral and the motivational data of the graduates. And the current implementations are time intensive and computationally intensive. Here is again a related work which are directly saying about this problem, which was published on Taiwan Scopes-based. It is demonstrating the importance of personalized and adaptive learning models. Aim of the work, and here was a constructed aim to solve this problem, and the aim of the work is to study and develop an AI-powered career prediction system based on academic, behavioral, motivational data to predict the future career positions of IT students. And the scientific novelty of the dissertation lies in the development and optimization of layer Kolmogorov-Arnold networks, architecture specifically adapted for career position prediction, and also making a first application of CAN in a field of educational career recommendation system. Provisions today. What provisions today I am submitting for defense? There is 3 provisions. It is about enhanced career recommendation accuracy, optimized CAN, Kolmogorov-Arnold networks, and integrated in a university framework. And to reach this submission, there was tasks which are objectives, and 5 objectives. It's data preparation, model training, model integrating, model evaluation, and model optimizing. Literature review in the work, there was here on the right side, you may see the statistics of the references which was used in the work. Here was used 230 references, and almost 70% is the scope-based publications, and monography books, conference paper are near to 23%. Other journals like Kazakhstan journals and other journals is 7.5%, and the published year of these works are between 2018 and 2025. And one of the work, for example, in Malaysia, which was published in Malaysia, says that the GPA had a little impact for the employment. And also there was a considered literature review in the local context. Have considered local professors' works. In the works, there's a Professor Mohamediev, Professor Kubekov, Professor Rabarov, Professor Bogdanchikov, and Professor Chikri's work. And these works are demonstrating the technical deployment of recommendation systems. And one of the work which helped me about the data set, it's Professor Japarov's works, where he is highlighting the importance of behavioral attributes and internships. And after that, I'm starting for the provision number 1, where the objective number 1 is data preparation. Here you may see the screenshots of the data sets, and data set was collected between 2020 till 2024, and it is including the features about the certifications, grades, other the skills, adaptability, ability rating, and interests. And this data set was collected through the internship program, which is named a Better Career Program. It is one of the unique programs in the Kazakhstan education system, which are helping for the students passing for full-time internships during their study. And near to 700 students, exactly 692 students data set was collected, and the collected data set was imbalanced. Almost 44% of the students were choosing the software development, whereas the data science was only 7.2%. And it is one of the risks. It is about the potential prediction bias toward the majority class. And here you may see the structure of the data set, which it was collected by 4 groups. It is career readiness, academic performance, personal attributes, and professional experience. In academic performance, it is the grades and GPA. The grades was also distributed in 2 parts. It is about core subjects and elective courses. And in personal attributes, it is personality type. It is only 2 options for the students, choosing between introvert and extrovert. Professional experience, it is about the certifications, hackathons, internships. And career readiness, it is about the stress resilience, adaptability, willingness, and so on. After how I collected the data sets, there was a question: is it enough to train the model or not? And have made a lot of research, and one of the directly saying about the size of data set, one of the work which was published in USA Department of Management Information Systems, saying that the data set between collected 40 till 10,000, it's okay to train the model. And the relevance to this work is that my data set is containing almost 700 students. And after how I made the size of the data set, I'm starting for data pre-processing process. It is containing 5 methodology. It is about data profiling, handling missing values, feature transformation, normalizing numerical features, and class balancing techniques. Here, data profiling was segmented in 3 segments. It's numerical, categorical, binary segmentation, where I'm taking in a numeric, it is all the numeric format of data set. And in a categorical, it is all the certifications, all the backgrounds of the students. And in a binary, it is rating of the skills. After how it was segmented, I'm starting for the handling the missing values. All the missing values of the numeric features was completed with the median imputation method, and the categorical features was completed by the mode imputation. And for high missingless cases was totally removed from the dataset. And encoding the categorical features, it's about the transformation. Here I'm starting to transfer the dataset for the numeric format to be readable for the machine learning models. And here are encoding and one-hot encoding methodology. And after that, how it was transferred for the numeric format. Here I'm doing the normalization of the dataset with the mean and max values to avoid the bias. Sorry, I think, yeah, my supervisor. Okay, after that, how it was normalized with the mean and max normalization. Here is the class balancing techniques was used the SMOT method, where I'm synthesizing the data and making the probability for all class minority, making it equal to the probability for all class majority for all classes. And after it is starting for the objective number 2, it's still provision number 1. It is about the model training and how I prepare the data set. I'm starting for the process of dividing the data set. The division of the data set was contained 2 sets, training set and testing set. In a training set, it is 80% of the data. In a testing set, it is 20%. And in a training set, it is model training and the 10-fold cross-validation. Later, I will talk about. In a testing set, it is formal and metrics. And why 10-fold cross-validation? I have compared it with a 5-fold cross-validation, and the results of 10-fold cross-validation was more reliable, more accurate. And the results of 5-fold cross-validation giving faster but not reliable and wasn't accurate, and that's why there was choosing the 10-fold cross-validation. Then testing set and models. The testing set was measured by the measurement of precision, accuracy, and F-measure, and have chosen the 9 algorithms, which are SVM, naive Bayes, KNN, gradient boosting, decision tree, random forest, MLP, TAP transformer, and Kolmogorov-Arnold networks. And the highest accuracy on the gradient boosting. Here you can see the confusion matrix of the gradient boosting, where it is showing the almost perfect results on a diagonal, where the misclassification is appearing on the map, but while we are comparing this result with the other model confusion matrix, here you can see the random forest, the KNN, naive Bayes, SVM confusion matrix. They are all on the map misclassification. And the confusion matrix of decision tree, MLP, TAP transformer, here it is almost near to perfect, but their accuracy was lowest than the gradient boosting. That's why we have here misclassifying on the map. And the rock curve of the model, here you can see the green color, which are trying to be on near to the left corner. It's saying that it is a gradient boosting, the green one, and it is the area under curve is 0.98. And the feature importance of analysis, here I have used the random forest classifier to find especially the methodology SHAP in a framework of tree explainer, where I'm finding the global feature importance ranking. And for the gradient boosting, there was a feature importance, and the top 3 features which was identified, it is stress resilience, adaptability, hackathon attendance, and teamwork ability. By the way, the hackathon, it is especially about the IT hackathons, not like overall hackathons. And the GPA was on the below. After here, it's a block diagram of the gradient boosting. Here, the gradient boosting is taking, gathering and preparing the necessary data for the model. After it is training the first weak learner to identify the initial patterns for the H1, and it is giving for the next step for analyzing the errors, and it is repeating for the F time. And here you can see the parameters of the gradient boosting, which was used in the model. It was a number of trees. It is between 100 till 500, and the best accuracy on the cross-validation was 99.10%, and training time was 65 seconds. And interpretability, it is depending on the importance of a feature. Now I'm going for the next objective. It is model evaluation. Now I'm starting evaluate the Kolmogorov-Arnold networks with the gradient boosting, and a little short introduction for the what is the Kolmogorov-Arnold networks. It is based on a theorem of Kolmogorov and Arnold plus networks. It's giving a shortly CAN. Before understanding the Kolmogorov, we have to compare it with the neural networks. It is the traditional neural networks, for example, the MLP, always taking the layers, working with the layers, and it is always searching for the minimum. It is always searching for the way to train the model, and it is when the best weight will be counted as the minimum one, and when it finds the minimum one, it is starting to train it. And how works the Kolmogorov-Arnold networks? It is instead of the layer, it is using the fixed sum, and instead of the weight, it is training the activate functions, fixed activated functions. And here we can see that it is searching for the minimum weight to find its function. And this here you may see that the function is changing depending on the searching for the minimum weight. And when it finds the minimum weight, it will be best function for training. And this function is called trainable functions, and always it is used for with the coefficient here on a fixed sum. It is multiplied by these functions. Here also the Kolmogorov network is using a B-splines. What's the B-splines? B-splines, it is now we are approximate the values of these functions, and these functions with these measures is trainable parameters. And also we have a constant B-splines where we are using the where we are dividing the function in the three groups, 3 parts, and each part is multiplied by 1, and then we are finding this. Sorry, I'm going back. And we are finding these approximate numbers, and these numbers is called keynote vectors, and these keynote vectors gonna be our trainable parameters which we are using in our network. And how it is working in our cases, when we, for example, when we here in our data set, we are predicting this position, backend developer, and we are taking the Kolmogorov, instead of writing the function for all the features, instead of that we are writing a multivariate function and summing them up with a function for each feature, and taking all the features inside of one function. And it is gonna repeat it by m times, and we are placing the function inside function, and these functions gonna be our activate trainable functions. And how optimizing the layer was happened in a standard Kolmogorov-Arnold networks. We there used the layers, and 3 inner layer, 2 outer layer, and it was optimized till 5 inner layer and 3 outer layer. And the inner layer is called functional layer, and outer layer called aggregation layer. And here it is the inner layer is identifying the non-linear dependencies and using B-spline in a cubic function, and working with the grid to measure the prediction. And the outer aggregation layer is generalizing the result of the inner layer and forming the final dependency. And it is helping to reduce the overfitting. Here, the B-splines, our B-splines, optimized version is trying to go by these B-splines, but each time here you may see the screenshot from the result. It is always when we the fixed sum, when the training the function, it is always trying to reach this B cubic function. And here you may see the interpretation of the CAN. It is depending on the function choosing their doing their doing their choice. Compare hyperparameters of CAN, standard CAN and optimized CAN. Here we may see the changes in a window length, hop length, and it is training time is decreased till 35 seconds, and accuracy was increased for 0.5%. And now I'm starting to evaluate the gradient boosting with the optimized CAN. Here the confusion matrix of the algorithms. Here, first one, it is optimized CAN. You may see that it is have only one misclassifying on the map. By what kind of parameters optimized CAN is good. It is in a training time. It is gradient boosting showing the 65 seconds, and it is half the optimized CAN is giving half of this time. And also memory usage in a gradient boosting, it is using 1.2 gigabits, and in a optimized version, it is using only 0.8 gigabits. Training time of all the models, the fastest was naive, slowest was gradient boosting. Here you may see the comparison of models in a cross-validation performance. The naive bias was the fastest, but its accuracy showing only 35 seconds. And the independent test set performance, here I want to say about the MLP and the TAP transformers. They are showing the strong results through all the metrics. Interpretation of the results, CAN is giving the highest results. The dataset characteristics strongly influence for the model performance. Future direction, it's investigating deep learning with a big dataset. Comparing analysis with the other work. After how I finished the work, I have compared it with the other works. There you may see the publication year of the works, and this is the newest one. And all these works is saying about the career path. My work saying about the 7 special IT positions, and these positions are project manager, cybersecurity specialist, front-end, back-end, mobile developer, network engineer, data scientist. And the last provision today I'm defending, it is integration, how the model was integrated. Here you may see the screenshots and codes, architectures. Practical implementation between study year 2023 and 2024, 2024 and 2025 was taking a survey, post-deployment survey, and this survey showed the satisfaction of the students was increased for 27%. Now I'm demonstrating the model, how it works. Okay.
Just explain how it works, so no need to show the product. Maybe during the questions you can show the results, okay?
Okay.
Return back.
Act of implementation, successfully implemented to the University of SDU. In conclusion, I want to say that gradient boosting initially showed the highest result, but optimized version of the Kolmogorov-Arnold networks was giving a highest accuracy among the gradient boosting. And also taking survey about the satisfaction of the students showed that it was increased for 27%. And if the framework was successfully integrated for the platform of better career at SDU University. Publications which I published, it is a 2 scopes paper. First one, it is directly about my topics, where I'm contributing all the works about the first publication. On the second publication of scopes based, my contribution was about doing the data set and analyzing the data set. And the third one, it is a conference paper, Intelligence Career Path Recommendation. It's about a blockchain. It's also about my topic, and the contribution was directly to this paper. And the 3 committee for quality assurance in science and higher education papers in ABA University, Vestnik AGA, and Vestnik KazTK. The first one is about my topic. Used references in the presentation, and thank you for your attention.
Thank you very much. Thank you, Bauyrzhan Berlikozha. The presentation is concluded, I assume. Please, questions about the presentation. Can you show the screen, please? Yeah, professors, you can raise a hand or just open microphone and speak.
Can I start?
Professor Lanza, yeah, please start.
Yeah. Okay, thank you, Mr. Bauyrzhan. Thank you for your presentation, for your committee, and for your supervisor. Okay, let me start directly with the questions. I just want to understand, like, how did you collect the data set? Like, is it by survey or kind of interviews?
It was collected by survey.
So I mean, like, do you have the result of that survey, or did you put it somewhere?
Yeah.
That just
In the presentation, it was put in here. Let me show it. Screenshots of first objective. Here, the screenshots of the survey where it is how it was collected.
so it's filled by participants, right? Not by you.
Yeah, it's fully from the participants.
Did
Okay.
you verify the
Okay.
data? Did
So
you verify
also,
the data, and so on?
sorry.
Did you make the verification?
Yeah, of course.
Okay, thank you. Just clarification,
Okay.
sorry.
Yeah. So I also noticed that you said like you have developed a layer. So where is that layer, and what is the effect of that layer?
Model layer.
Sorry, I didn't catch the question. Saying about
I mean,
layer.
is it my voice clear, or there is echo in my voice or something?
Oh, it's okay. It's okay. Your voice is
Okay.
okay.
So I mean, like you said, you have developed a layer, right? And I just want to know, like, which layer that you have developed, and what is the effect, like the layer that effect on the result?
Yeah. Okay, thank you, Professor. Yeah, your voice was clear. I think I'm a little bit worried. Yeah. So the layer which was modified in the algorithm, it is inner layer and outer layer. There's in a standard Kolmogorov-Arnold network, there's a 3 inner layer. This layer is called functional layers, and it was optimized for like decreased the number of layers for the 5.
Can you just maximize? I can't see actually. If you can just maximize the screen, just make it full screen, please. Yeah.
Yeah. And the outer layer is called aggregation layers in the Kolmogorov-Arnold networks, and this outer layer was increased for 1 layer, like past 1 layer. In standard, it is 2 layers. In optimized version, it is gonna be 3 layers. And these layers is making effect for here you may see the we are changing the grid, and grid it is a parameters that determining the balance between accuracy of approximation and the computational complexity. And while we are making grid more, the errors are lower. And optimize.
I mean, like you made it from, it was 3 layers and you made it 5 layers, isn't it?
Yes.
Yeah, so I mean, now where can you just indicate in the result where is the effect of that layer, and what is that layer actually? You said inner layer and outer layer. So what do you mean by inner layer, outer layer?
Yeah, it is in a Kolmogorov-Arnold networks. It is the layers which are, instead of using the layer like in a MLP, like sigmoid or some other layers, in a Kolmogorov, it is using, instead of the layer, a fixed sum. And between the
Yeah, I mean,
input
this
and
layer
fixed
that
sum.
you add, it seems that you add 2 more layers. So
Yes.
what these that the first layer is doing what, second layer is doing what is the effect of each layer? What is the parameter of that layer or something like this?
Yeah. Each layer is taking a different function each time, and in each this function is activate trainable functions, and depending the results, it is giving for the next layer. Next layer is taking another function, and so on. It's continuing.
Yeah, this is my question. What is that function? What is that function that it's taking? Or what is the things that are taken by these layers?
Yeah, there's 6 functions which was used in the algorithm, and it is depending on the dataset features. Like if it's about GPA, it is using the special functions. If it is about phase transition, it is about when the certifications and so on.
Why do you mean about phase something? But your work is not about phase and so on.
Yeah, I agree that my work is not about the phase transition. The phase transition, it is one of the functions which was used in the work.
So you
tangent 5
Yes,
equals
yes.
401, this function, right?
Yes, it's here mentioned like in the presentation.
So please show it. Yeah.
Okay. So can you go to page 19 in your slides? You mentioned about some algorithm, page 19.
19?
Yeah, I mean, yeah, this one. Is it your result?
Yeah, it's my results of.
So which one is your algorithms, or which one you have developed in the
Yeah.
result?
Okay, thank you for saying that. On the first part of presentation, I am talking about the gradient boosting, and the gradient boosting was one of the highest, showing one of the highest results among all the algorithms. So that's why here the gradient boosting making success, and I'm showing his results. And after that, I'm comparing the gradient boosting results with the Kolmogorov, optimized Kolmogorov.
So I mean, I noticed that at the end you mentioned about KN algorithm. It's better than gradient boosting, right?
Yes.
So you didn't include that algorithm.
Yes, because here is the results of the gradient boosting.
Okay.
And highlighting the gradient boosting results. And after that, I'm comparing it with optimized Kolmogorov or Arnold networks.
Okay. So I will give you the bunch of my question to just finish the my question at one time. So I just want you to take all my question. I mean, the second one, another question is, what is in your objective 4? You have mentioned about objective 4, but I didn't know what is your contribution in objective 4.
Am I answering or waiting for all your questions?
Sorry?
Yeah, okay. Here, model evaluation. Here, I'm identifying that gradient boosting is the highest results among all of the algorithms, and after that, I'm evaluating the results of the gradient boosting with the optimized Kolmogorov-Arnold networks.
So you mean objective 4 is just for evaluating the accuracy or effectiveness of...
The name of the objective 4 is model evaluation.
Actually, this is like kind of the result of your dissertation. You don't need to consider it as objective, because it's eventually, after you do the research, you have to have evaluation to show the performance. So I suggest for you that to not call it as objective, because you must do it. It's not objective. You must do evaluation for your result, right? So it's not it's not considered an objective of the dissertation. It should be there, you know. So I just
Okay,
suggest
thank you
for
for
you
your
to
feedback. Yeah.
change that one. And again in page 35, you mention again about optimizing the layer. Is there any difference or this is the optimizing layer that you
Yes,
have
yes, it's
mentioned
optimizing.
in the beginning of the slide? It's the same.
Yes.
Okay.
Which I showed
Okay.
on the beginning. Yeah.
I just want to have a look on page 38. You just pass it very fast. So in page 30, yeah, 38. So here this is the comparison between the one with the normal layers and the one with optimized layers, right?
Yes, yes, yes. It's normal layer, like standard Kolmogorov Arnold networks architecture with comparison with the optimized CAN, where the number of the layer was changed. And by the parameters of training time and accuracy, the optimized version of CAN is showing best results, depending on the standard CAN.
So your accuracy it's with 5 layer is less than the accuracy with the standard layers. If you see the result here. Correct?
No, optimized
Yeah.
version.
Yeah, is 99.32 here 90 oh 99 sorry
Yes, it's much bigger. Yeah. Little bit.
But
Okay.
how come you have more layers and training time is less?
It is because window length was decreased, and it's one of
I
the
see.
reasons that's why it is the time is smaller.
I see. Okay, thank
Okay.
you so much. Thank you.
Okay,
I have
thank
no
you.
more questions.
Thank you,
Professor,
Thank you.
Professor Aygerim Yerimbeto, you have a question, please?
Yes, I have some questions. First question, how can your system be scaled to other Kazakhstani universities?
Thank you, Professor, for your question. Let me repeat your question to answer clearly. Your question sounds like how my system can be integrated for
Can
other
your system be scaled to other Kazakhstani universities? Yes.
Scale it or integrated?
Use it or scale it.
Use it. Oh, okay. Thank you.
Yeah.
Now I got you. How my system can be used in the other university?
Yes.
It depends on the data set. If there will be the data set in the other university, the system easily can be integrated for the other university framework.
Elaborate.
Yes. Next question. Did
Also
you consider
collaboration.
deeper?
Sorry.
Yes. Next question. Did you consider deeper architecture such as maybe transformers, LLM based models?
I have taken the MLP tap transformer, but didn't consider the architecture inside. Just have used it for identifying the accuracy. Just it.
Okay, thank you.
Okay, thank you.
Thank you, Professor.
Others? Yeah, Professor Dana. Yeah.
Thank you. I have some specific questions related to your thesis. The first question, could you move to page 35, please?
Yes.
So here you mentioned that you are optimizing three. So you are leaving 3 inner layers and 5 outer layers. So if you could see first scheme on your page, you are taking outputs from inner layers, 5 more. So not repeating some vector data is repeating here. So how did you try to change? How did you try to solve the overfitting problem here? Because you are repeating your vector data coming. If you see from x1 to x2, you are taking same outputs from first inner layers. So as I understood, you mentioned about L2 regularization layer. So how did you choose it? By chance or by empirical method or by literature review? How did you choose this architecture if we compare with standard CAN?
Yeah, sure. There is a risk of overfitting, and to prevent it, there was used a smooth functional decay. For the regularization of the overfitting.
So why you didn't use dropout, for example? Why you didn't use layer of normalization like batch normalization? So why you did choose L2, specifically L2? There are other layers like L1, L2. So what is the coefficient for that? If it's possible to see from your experimental work.
Yeah, actually, did not consider it deeply. It was like a classic method of to prevent the overfitting, and it is good fits with the Kolmogorov-Arnold network, so that's why I have chosen.
So you mean you had chosen it from literature review or from previous works?
Yes.
Which was better one? You didn't try by yourself?
Yes, I didn't try by myself. I just from the literature review, seeing from the literature review the other works results, and that's why it was chosen.
And next question is, so how did you choose Kolmogorov-Khan methods, by empirical way or literature review or by chance? Because on your first part of experimental series, it was chosen gradient boosting, right? There are a lot of neural networks, deep learning models. So why you did choose specifically Khan?
First,
Okay.
Thank you for your question. The first reason of choosing the Kolmogorov-Arnold networks, the Kolmogorov-Arnold networks is making success in the field of physics, energy, industrial, but not still implemented for the career recommendation system in academic field. It was first reason. And the second reason, it's obviously it is from the literature review.
So, okay. So you tried to look for newest neural networks,
Yes,
right?
newest.
So what was the reason? Why did you decide to choose new neural networks? Because you have already almost 100%, it's 98% accuracy, is almost close to 100%. So why you are still looking for better neural network?
Because the current implementations are very time intensive and computationally intensive. I want to decrease this one.
So you mean training time and computational resource?
Yes, like memory resource, time. And I wanted to decrease these parameters. So that's why I choose the newest, which wasn't implemented in a recommendation system.
Okay, so how many times did you try to look for new optimized layers for your proposed system from rather than your standard one? So what was the reason to look for new neural network from standard one? Because your standard Khan, if you move to the results, they're 42 seconds. They're like
42 seconds.
Same. Yep. Why did you look for farther?
Because the accuracy was a little bit small, so that's why we move it forward to optimize, to modify it, and to get a higher accuracy than the gradient boosting, where the gradient boosting using a lot of memory and using in a prediction time, it's using a lot of time.
So you have chosen your data set 7 specialties, yes, for 7 specialties. Why specifically 7? So they are famous chosen specialties, or could you move to next slide, like at the end?
About data set?
No. Chosen specialties. Chosen. Мамандықтарын таңдаған.
Positions. You mean positions?
Yeah. Why these are chosen?
Why these positions was chosen? Because the data set was collected among the students from the computer science and information system students. And the most famous positions after graduation, they are working on this specialty. on these positions. So that's why these positions was chosen.
You mentioned about act of implementation. So what problem was, what or solution product was implemented in your act? So was it used with proposed system with CAN?
Yes. Yeah. May I answer?
Yeah.
Okay. Let me show you my results here. It is using firstly it is using for the Better Career platform. Here we are starting, and the data set which is taking inside the algorithm, it is divided in 4 groups. Here you may see it. Let's choose the random data to see the results. And first one, it's career readiness, where the students are feeling about career orientation, motivational factors, languages, certifications like IELTS, TOEFL, and Duolingo.
Thank you. Can I interrupt you? So what in your thesis topic, it's mentioned behavioral data. So what do you mean here, behavioral data?
Yeah, it is about here. So let me move for the academic field. It is here. It is professional experience. It is a behavioral data where the students are participating in some clubs, for example, IT clubs, to see the results. Capstone research projects.
Okay, so before they're graduating, which they have some skills.
Yes,
like that.
to rate
Thank you.
this one.
Next question is about your data set. Is it balanced data set in your case for each category or imbalanced?
When I collected the data set among the students, it was imbalanced. Most students were choosing the data science, software development. The data science was only 7.2%. And the imbalance issues will solve it with a SMOT methodology.
Okay, thank you. That's
okay. Thank you very much. Any other questions, please? Committee members? Okay, let me have a small question. So you already shown your platform, it's working. So I assume you have some people who are going to use this platform, and it can be useful for our students and other university students, right? Do you have any plans for that? Okay.
I guess, yeah, we
Okay.
can consider it.
Okay, wonderful. The next question is about also the positions. You mentioned the front and back end software engineering and all others. And so currently we see that the job market is changing so a lot. And can you predict or maybe plan for the changes in the job market? Can your platform adapt to these changes so that, I don't know, AI prompter, I don't know, AI engineer, any other professions will come up that are very necessary? And can your system also suggest for the people to participate in these positions? Yeah.
Very interesting questions, actually, to be honest. Why? Because in Kazakhstan, we have atlas of professionals, which will be developed in the futures. I think we may adapt if we will get the information about educational, if we will get the context to the educational program of this specialty. If we will go deeply for this specialty, I think I can adapt this algorithm for the future coming professions.
Okay. So it's more about the manual work, not just some, I don't know, intuitive work of the system.
Yes, it's manual work. Yeah.
Okay, thank you very much. Any other questions? Please. From online presenters, can you open the screen, please? Yeah. Taligen Akhmetov, please. You have a question?
Hello,
Mike.
can you hear me?
Yeah, please.
Thank you for your presentation, Mr. Bauyrzhan. So you addressed a very important topic, this career path prediction. Yeah, it was interesting. So I have a few questions. First of all, I'm not familiar with the literature of career path prediction, but do you think that using this quantitative measurements enough to predict the future paths, for example? Was there some other kind of studies? Were there some studies who addressed this problem by considering qualitative feedback from the participants?
Thank you, Professor, for your questions. If I'm understanding your question in the right way, the algorithm can be worked for all the specialty. You mean not only IT, right?
Not exactly. Yeah, for example, most of your data set is quantifiable, yeah, as far as I understood. And so you have used some given number of features, for example, like in your survey, yeah, for example,
Yes.
all of them are quantifiable. Do you think that it's enough for predicting the future career paths?
Okay,
Yeah.
now I got you. Thank you for your clarifying your question. The question is like, why only these features in the data set?
Yeah.
Yeah. Actually, in a literature review, I have considered like a lot of works where the systems are taking into account only the academic aspects. Depending from these works, this data set includes the motivational and behavioral data of the students, like certifications, competitiveness in the IT fields, and so on. And the results is showing, and the satisfaction of the students was increased for the 27%, and the results is saying that for now it's enough.
Okay. Yeah. Thank you. Yeah. So yeah, I think that using some AI, like explainable AI, could also help to predict more precisely. Yeah. So in the future. Yeah. So yeah, these are my ideas only. And next question might sound silly, but you've told that there are seven positions, yeah? So as far as I understood, you are categorizing all this in your training data set to the 7 categories, yeah? Did I understand correctly?
4 categories. The
4
data set
categories.
is 4 categories, yeah.
What kind of categories are they?
Career readiness, professional experience.
Okay. So, okay. So, for
Yes.
example, you are giving, for example, X's and Y's, for example, you have given some all these survey features, yeah, for example, and what your model should predict, for example, the future career or
It's exactly the positions. Exactly
yeah.
the position.
Okay. So you have mentioned about 7 positions, yeah. So it
Yes,
starts
7
from 0
positions.
to 6, yeah. So it should show one of them, yeah. If I'm
Yes.
not mistaken. Okay, got it.
Yeah.
Next question will be more kind of specific. Yeah. So can you go to slide 35? Yeah. Yeah, there you have mentioned about avoiding overfitting. So how did you manage doing that way? So for example, what kind of techniques you did, yeah, to
Yeah.
make it generalizable, yeah?
To prevent the overfitting, there was a regularization. In a CAN, it is a smooth functional penalty was used to prevent the overfitting.
Okay, next question. Let me ask from another perspective. If you go to slide 45, you have told that the sensitivity to overfitting is low. Do you have some metrics that shows that it has a low overfitting sensitivity? Yeah. 41, if I'm not mistaken, yeah. Yeah, so you have shown here in one of the kind of rows overfitting sensitivity high, and the next one low. Yeah.
Okay, it is a comparative analysis between gradient boosting and the Kolmogorov-Arnold networks, optimized Kolmogorov-Arnold networks. And here the overfitting sensitivity is low and high. It is comparing with the gradient boosting. With the comparison format of the gradient boosting, it is making a low sensitivity for overfitting.
Okay, so we are engineers, yeah? So is there any kind of numerical kind of value that shows that it has low it's the low sensitive to overfitting, and the second one is it has a high overfitting. So is that a kind of empirical or kind of estimations?
Yes, you are right. It was mentioned high and low depending on the training time.
I see. Yeah, so let me ask less questions. I have so can you go to slide 27 then? Yeah.
27.
Yeah, so you were talking about this global minima and yeah, so local minima, and yeah, again, you have mentioned about two types of layers, yeah. So aggregation, and the second one's functional layers, yeah.
Yeah, functional layer, aggregation layer, outer aggregation layer.
Okay, here, for example, you are showing that it is getting stuck in the local minima, and the next slide you are mentioning that it's getting to the global minima, yeah. So you are mentioning here about the optimized and the regular CAN, or are they the same algorithm? Yeah.
It is a overall structure of the Kolmogorov-Arnold networks, how it works. It's searching for the best function by finding the minimum weight, and it is like two inputs between the fixed sum, and how it works. It is for the standard.
Okay. And yeah, last question, if you don't mind. Yeah.
Please,
yeah, about this confusion matrix. So I forgot which slides are they. So you thought that they are perfect, and yeah. So these are GB and CANs. Yeah, gradient boosting.
Gradient boosting.
Okay, so here the numbers are the classes are imbalanced, if I'm not mistaken. Some of them are showing high number. Yeah, there are less kind of misclassifications. Yeah, I can see, but in the diagonal line we can see that some of them have
different numbers. Yeah.
Yeah. So why it is showing that way? Yeah.
It depends on the data set features which are taken into account. Yeah.
Thank you, Mr. Bauyrzhan. Yeah.
Yeah, thank you very much, Professor. Can you remove the share screen? Do we have any other questions? If there is no, we can move to the next stage. Okay. So now we're going to give a speech to the domestic scientific advisor, Dr. Azamat Jamanov. Please, floor is yours.
Can you hear me, guys?
Yep.
Thank you so much for being here, dear chair, distinguished members of the committee. So it's my privilege to present my student, PhD student Bauyrzhan Berlikozha, with whom we are working for starting from his bachelor degree. So he defended today his topic, AI-powered approach to career path prediction for IT students using academic and behavioral data. In my personal opinion, this topic complies with, like Bauyrzhan said, in Kazakhstani and global context. So throughout his work, Bauyrzhan has successfully completed major tasks of the dissertation. A unique multi-dimensional data set of IT students was collected and processed, reflecting both academic progression and behavioral characteristics. A wide range of machine learning algorithms were evaluated, and the gradient boosting demonstrated the highest performance across the K metrics, including F1 score, ROC, and area under the curve. I would like to underline several key contributions of the dissertation, including scientific significance, practical application, and research development. In the scientific significance, the dissertation advanced the field of educational data mining by integrating diverse student data categories into a career prediction model, addressing an existing gap in predictive analytics literature. In practical application, the proposed model and framework can serve a valuable tool for university career centers, enabling more personalized student advising and contribution to improved employability outcomes. And in the research development throughout this work, the candidate has demonstrated independence, methodological precision, and the ability to critically evaluate and improve his models. Dear committee members, based on the completed research, its scientific and practical value, and the candidates demonstrate competence, I believe that Bauyrzhan has fully completed and met requirements of the PhD degree. I confidently support his dissertation, and I hope to see him as a PhD holder soon. And I'm very thankful for everyone who've been asking for such detailed questions, really, so I felt that Bauyrzhan really was participating in his defense. Thank you so much.
Thank you, Professor. Okay, then the speech is given to the foreign scientific advisor, Oliver Diaz, please.
Hello, can you hear me?
Yep.
Okay, thank you. So from my point of view, I've been I met Bauka and Azamat a couple of years ago. They came to the University of Barcelona, and then we sort of start this collaboration. And Bauka got this idea, right? Of he was at that time he was a coordinator of the career path at the university, and he got these ideas of applying, right, some technology he have learned over the years to this complex sort of a problem of kind of recommend for the different students to take one path or another, right? So given the current situation where we don't know what's coming in the future, especially with the artificial intelligence and so on, I think this such tool that Bauka has been sort of working on the last years. So I think it's quite important, since that will allow prospective students to sort of select sort of optimize a career path and sort of improve their skills to be more competitive when they arrive to the market. That it seems to be more and more complex in the next years, especially with the technology, with the development of the different technology. So over these years, Bauka and I, we had some regular meetings, and he came to Barcelona and he spent some time here, and we have been discussing the different technology, the different applications, and what you have seen from his presentation. He has not only developed the methodological framework, but he also has tested, such models, such tools into sort of like a real, with real data set environment, and that sort of like add some kind of like a real value or added value to what he already have developed. From my point of view, he has, already been peer reviewed by the community, as he's shown. He has a couple of publications in journals, as well as, he has had the time to discuss some of his results and development with the international community. And that's sort of like, he also demonstrated his contribution to the field, and I think, my recommendation at this stage is, to really continue to sort of like support his application for the PhD sort of like a degree. Thank you.
Thank you very much, Professor. Thank you. Okay, then we're going to move to the next stage, discussion of the dissertation. So now we have two official reviewers, and speech is given to the official reviewer, Mrs. Madina Mansurova. Please, stage is yours.
Dear colleagues, I'm very glad to participate in this defense procedure. Let me read my short version of my official review on the dissertation work of Berlikozha Bauyrzhan Assetula, who is an applicant for the degree of the Doctor of Philosophy in the education program 8D06102, Computer Science. The dissertation corresponds to the priority directions of scientific development, including the achievement of AI and information technologies. The research focused on the study and development of a system for predicting the career trajectories of IT students based on academic and behavioral data using artificial intelligence technologies. The author independently conducted an analysis of existing machine learning models, optimized the Kolmogorov-Arnold network, performed the model testing, and evaluated the efficiency and performance of the proposed AI model with a focus on three key parameters: memory usage, computational efficiency, and accuracy compared to existing methods. The relevance of the topic is justified by global trends of digitalization of education and the growing role of AI in personalized learning and career counseling. We know that nowadays our government pays big attention for digitalization in different areas, especially in higher education. All objectives logically relieve the stage of achieving the main goal, from collecting and pre-processing multidimensional student.
Do you have issues on our side?
Open an application for career path prediction and study of the proposed model using real university data. The author proposed an improvement architecture of Kolmogorov-Arnold network adapted for educational data and experimentally demonstrated its advantage over traditional models in terms of, as I said, the parameters and explainability of dissertation presents an integrated AI framework. It introduced a hybrid model that combines classical algorithms with Kolmogorov-Arnold network and the top transformer architecture, ensuring interpretability and adaptability. Comparative analysis demonstrates that the proposed models outperform traditional methods, while the scientific novelty lies in the application of KNE to educational data and the development of an artificial intelligence framework adapted to the higher education system of Kazakhstan. The key statements of the dissertation are experimentally validated, and the theoretical foundations are supported by empirical results obtained using modern ML methods. The work presents an innovative integration of gradient boosting, tap transformer, and Kolmogorov-Arnold networks for reliable and interpretable career trajectory prediction. Scientific quality is confirmed by a publication in the Scopus Indexed Journal with a higher percentage. The proposed algorithms provide effective solutions to the challenge of modern academic and career counseling, enabling scalable AI-based prediction of IT students' professional trajectories with accurate, data-driven, and personalized recommendations aligned with the labor market demands. And as a conclusion, the dissertation work of Berlikozha Bauyrzhan entitled The AI-Powered Approach to Career Path Prediction for IT Students Using Academic and Behavioral Data fully meets all the requirements set by the Committee of Quality Assurance in Science and Higher Education of the Ministry of Science and Higher Education of the Republic of Kazakhstan. The author, Berlikozha Bauyrzhan is worthy of being awarded the degree of Doctor of Philosophy, PhD in the educational program 8D06102 Computer Science. Thank you for your attention.
Thank you very much, Professor. Did you had any comments for the dissertation in your review?
No, because before this procedure, defense procedure, we discussed some points and I received all the answers to my questions.
Okay, thank you very
No
much.
remarks.
Yeah, okay.
Thank you.
Then we're going to move to the next reviewer, Professor Rustam Abdurrahmanov. Floor is yours.
Саламатсыздар комиссия мүшелері, қайырлы күн. Рұқсат етсеңіздер, қазақ тілінде қысқаша айтып өтсем.
Жақсы.
Тақырыптың Берlikozha Bauyrzhan Assetұлының диссертациялық жұмысының тақырыбының өзектілігінің және сәйкес болуы. Диссертация ғылымның даму бағыттарына толық сәйкес келеді. Жоғары оқу орындарында жасанды интеллект негізіндегі мансаптық болжауды жетілдіруге бағытталған. Зерттеу өзекті, практикалық құндылығы жоғары. Жұмыс білім беру аналитикасы мен жасанды интеллект саласына елеулі үлес қосады. Академиялық, мінез-құлық және мотивациялық деректерді біріктіретін тұтас болжамдық модель ұсынылған. Кан архитектурасын қолдану жаңа ғылыми шешім. Диссертация автордың дербес ғылыми еңбегі, әдіснамалық жолы модельдер, құрастыру және эксперименттік талдаулар толыққанды орындалған. Диссертацияның мақсаттары, міндеттері, мазмұны және қорытындылары бір-бірімен толық үйлеседі. Материал айқын, құрылымды, бөлімдер өзара логикалық байланыста. Жаңалығына келсек, Кан архитектурасын оптимизациясы негізінде жасанды интеллект құрылымы алғаш рет қазақстандық білім беру контекстінде қолданылған. Алынған нәтижелердің көпшілігі жаңа және ғылымға нақты үлес қосады. Теориялық тұжырымдамалар эксперименттік түрде дәлелденген. Кан моделі ең жоғары нәтижелер көрсетіп, 99.32%. Классикалық әдістерден асып түскен зерттеулер диссертанттың Scopus журналдарында жарық көрген мақалаларını көруге болады. Қорғауға шығарылған ережелер барлығы негізі ережелер дәлелденген, тривиалды емес, жаңашыл және кең қолдану мүмкіндігіне ие. Әдіснама негізделген заманауи жасанды интеллект модельдері орынды қолданылған. Теориялық қорытындылар толықтай эксперименттік нәтижелермен расталған. Алынған нәтижелер университеттерде мансаптық бағдар жүйелерін жетілдіруге тікелей қолданылуы мүмкін. Ұсынылған жасанды интеллект жүйелері масштабталатын және тиімді. Жазу сапасына келсек, академиялық стиль сақталған, ішінде майда ұсақ техникалық қателіктер бар, ол жалпы сапаға әсер етпейді. Елеулі ескертулер жоқ. Жалпы алғанда диссертациялық жұмыс 8D06-102 компьютерлік ғылымдар білім беру бағдарламасы бойынша философия докторы ғылыми дәрежесін беру талаптарына толық сәйкес келеді және авторды PhD дәрежесін ұсынуға болады деп есептеймін.
Жақсы.
Назарларыңызға рахмет.
Рахмет сізге, профессорымыз. Жақсы, кандидат, жауап айтасыз ба бір нәрсе? Комменттер, кемшіліктер болды?
Кемшіліктерді жұмысты барысында диссертант ол жұмыстарды түзеді. Жұмыс барысында.
Жақсы. Жақсы, рахмет онда. Thank you very much. Thank you, dear members of the Dissertation Council. We move to the next stage, this dissertation, discussion of the dissertation. Who would like to speak? So maybe open floor to have their own appearance expressed. Dissertation Council members, maybe you can speak some words about the candidate and the proceedings. Anyone? Maybe Bauyrzhan.
So thank you, Mr. Bauyrzhan. I congratulate you and I wish you the best of luck in your endeavors. Thank you so much.
We'll see about that.
Okay. Thank you, Professor.
Yeah, maybe Mr. Bauyrzhan Omarov, Professor, maybe you can tell us a couple words about the proceedings. Microphone. Microphone questions. Please open the mic. Simon. Microphone. Doesn't change. Okay, maybe for now we can give a floor for Dana, Professor. Yeah.
So, мемлекеттік тілде сұрайын сізден, мен сіздің мақалаларыңызды қарадым, ол басқа бірінші бөліктегі зерттеулермен жасалған. Мен өте жақсы нәтижелер алғансыз. Қандай болашақ жұмыстар жоспарлап отырсыз? Алынған нәтижелеріңіз диссертацияда көрінген, әрине, бірақ оны публикация ретінде жоспарыңыз бар ма?
Қазақша?
Өзіңіз таңдаңыз.
Алғашқы жұмыстарым, ол жаңа публикацияларда шықты, Скопуста. Кейінгі жаңа Колмогоровты, яғни Колмогоровпен алған результаттарымды мен болашақта жаңа статья жазып, оны публикация жасау деген жоспарым бар.
Басқа жалпы канмен қолданылған proposed system бар ғой, ұсынып отқан жүйеңізді университетте қолданып көрдіңіз ба? Студенттер арасында.
Студенттер арасында енді қолданамыз.
Okay, thank you. Maybe others would like to speak from the committee members? Professor Bauyrzhan Omarov, he's trying to connect. You have some technical issues. Okay, I will express some words. So I know actually. Yeah, okay, I get him, please.
So thank you. I think, in my opinion, this dissertation is strongly relevant and well-executed piece of research. And the doctoral candidate has demonstrated clear understanding of the topic and obtained meaningful results with both theoretical and practice significance. And I think the presentation was confident and answers to the questions showed deep knowledge of the subject. And I fully support the candidate and believe that deserve the degree, PhD degree. Thank you.
Thank you. Thank you very much. Okay, I also express some opinions. So I have been working before with Bauyrzhan Berlikozha, so I know him as a student. I have taught him some classes maybe, and I see here a very confident person who is really knows his stuff and prepared for the work. And during his PhD studies, has performed some work. And during today's council meeting, he expressed most of the key points of his work, and I think that we could support him. Yeah, thank you. Maybe Bauyrzhan Umarov, are you ready now to?
Okay. So can you hear me?
Yes, please. We can hear.
Okay. So sorry for inconvenience, some technical problem. So I think the problem is very interesting and actual. So and the methods that used the PhD candidate Bauyrzhan Berlikozha, so is very interesting and very new. Kolmogorov-Arnold networks and applying it in education problem. So I think the study, the research was very interesting and very actual, and also I think the PhD candidate gained his goal.
Thank
So
you.
it was very interesting and very good work. Thank you.
Okay, thank you very much. So I think that we can conclude this session. So it should be enough for now. Okay, is it? Yeah, can we continue? So dear council members, according to the regulations, we now proceed to the secret voting procedure. To conduct the procedure, we need to elect the counting commission. Are there any proposals? So since we have many people online, so we need to select at least one person offline. So I propose Dana Utbayeva for the chairman of the counting council, and couple of people from online chairmen. So who can be proposal? Professor Mohammed and Toligan Akhmetov. Are you okay with that?
Okay.
So you just see the results, and together we'll announce concluding results. Maybe Dana can help you. Okay. Yeah, thank you. So if no one is against that, so we approve that. Okay, we now proceed to the voting. Is it? Can we proceed? Yes. Yes. So we need to do that. No one against that. The council commission has been elected elected, and asked the counting commission to proceed with the work. So now we need to announce a break for secret voting. Okay, so a break for others can. Thank you very much. I believe we will share with you some link in your chat. Yeah, and then you can vote there, committee members, please. Okay, check the WhatsApp group. All are welcome. Welcome. Please come in. The results are going to be announced. All are present? Yeah. Okay. So where is it? Please, recording. Should we continue? Yeah. Okay. Yes. So we resume the work of the dissertation council to announce the results of the secret voting. The floor is given to the chairperson of the counting commission, Dana Utbayeva, please.
Thank you. So the minute is in Kazakh state language. So I would like to give about voting results in Kazakh language. СДУ университеті мекемесінде 8.06.102 компьютерлік ғылымдар білім беру бағдарламасы бойынша диссертациялық кеңеспен сайланған комиссияның бірінші хаттамасы бойынша есептеу комиссиясының төрағасы ол мен Утебаева Дана Жолдыбайқызы, мүшелері профессор Алянзи және профессор Төлеген Ахметов. Есеп комиссиясы Берліқожа Бауыржанға 8.06.102 компьютерлік ғылымдар білім беру бағдарламасы бойынша PhD дәрежесі үшін AI-powered approach to career path prediction for IT students using academic and behavior data деген тақырыпта диссертация қорғау бойынша жасырын дауыс берді. Жасырын дауыс берудің несі бойынша, нәтижелер бойынша кеңес мәжілісінде 8 кеңес мүшесі қатысты. Жасырын дауыс беруге 2 ресми рецензенттер қатысты. Олардың дауыстары диссертациялық кеңес мүшелерінің дауыстарына тең. Және жасырын дауыс беру электронды форматта өткізілді. толтырылған электрондық бюллетендер саны 8, жарамсыз бюллетендер 0, философия докторы PhD немесе бейіні бойынша ғылыми дәрежесін беру бойынша так 87-де 5% ғылыми дәрежесін беру туралы дауыс берді. 12-де 2% диссертацияны, яғни бір адам диссертацияны қайта қорғауға жіберу туралы дауыс берді. Есептеу комиссиясының нәтижелері осындай.
Жақсы. So we should approve the consult. It means that from 8 people, 7 are for the approving the PhD degree. That is in favor of the approval. So can we approve the protocol? Yes. Who is against? No. So the protocol of the County Commission is approved. Thank you. Then the dissertation concept for the education program 8D06102 computer science at the university based on the public defense of the dissertation of Bauyrzhan Berlikozha on the topic AI-powered approach to career path prediction for IT students using academic and behavioral data has decided to petition the committee for the awarding of the degree of Doctor of Philosophy PhD or Doctor of Science in the profile. So we're going to petition for the ministry. Thank you. The coordinator is giving the floor for final remarks.
Thank you. I want to thank all the university, SDU University, for giving this PhD studying years. I want to thank my family. I want to thank my supervisors, Professor Azamat Jamanov, and my external supervisor, Professor Oliver Diaz. And I want to thank my reviewers for giving the feedbacks. And I want to thank my colleagues, my friends who were supporting during this way. Thank you.
Thank you very much. So the dissertation course is concluded. Thank you. My congratulations to the candidate. Yeah, thank you.
Thanks everyone, and congratulations.